Hello everyone, today I'm gonna solve you a question about the polynomial. Here is a polynomial f of x equals x minus 1 times x squared plus 2 minus k times x plus k squared. At the first question, show that x equals 1 cannot be a root of the quadratic factor x squared plus 2 minus k times x plus k squared. So when we substitute x equal 1 into this expression, it shouldn't be equal 0. I mean, 1 squared plus 2 minus k times 1 plus k squared shouldn't be equal 0. So I will simplify this expression, k squared plus 2 minus k plus 1, which is k squared minus k plus 3. So when we check for the discriminant here, we're going to see, and I know this, the coefficient of this expression here, 1, minus 1, and 3. The discriminant here, minus 1 squared, minus 4 times 1 times 3, which is 1 minus 12, less than 0, right? It means when we substitute 1 into this expression here, there is no solution, and x equal 1 cannot be root for the quadratic factor here. So if you go to the second question, here is find the values of k in each of the following cases if the polynomial has exactly one real root. Yeah, we know that x equals 1 already a root, since when we substitute here x minus 1 to 1, it will be 0. So we already know that the polynomial has a root which is 1. So it shouldn't be any other roots except from 1. So actually we will make the same. Uh, Here I will write the polynomial again, x minus 1 times x squared plus 2 minus k times x plus k squared. Yeah, we know that there is already roots here, which is x equals 1. So it shouldn't be any root from here. In this case, we're going to check the discriminant of this expression, the function. It should be less than 0, right? If we are asking for no solution here. So how we're going to check for the discriminant here? We already know that the coefficient of this expression, which is the leading coefficient, is 1, and the coefficient of the x is 2 minus k, and the constant here is k squared. So delta 2 minus k squared minus 4 times 1 times k squared. We know that if the expression is like a times x squared plus b times 6 plus c, and we are asking for the discriminant of this expression, it should be b squared minus 4 times a times c. And that's why I apply the formula here like this. So in this case, when we simplify this expression here, we'll see 4 minus 4 times k plus k squared minus 4 times k squared. And from here, minus 3 times k squared minus 4 times k plus 3. We are looking for this expression need to be less than 0. So how we're gonna check for the possible k values here from here? We need sign table. What's sign table? Yeah. So when we check the root of this expression, I mean the zeros of this expression, by the way, you can multiply by minus 1 this expression. I usually make like that, which is 3 times k squared plus 4 times k minus 4. In this case, the sign gonna, uh, the direction will be changed, so it will be greater than 0 instead. So what's the root of this expression? 3 times k. The when we factorize this expression, we will see like, and the factorize of minus 4, we can use 2 and minus 2. Actually, we need to change the place of this minus 2 and 2, because you know that if we make a cross product here and we add each other this the values, it needs to be 4 times k. So if you factorize this expression, we will see 3 times k minus 2 times k plus 2 need to be greater than 0, right? Yeah. So what's the zero of these factors? The first one is k equals 2 over 3, you can see, and the second one is k equals minus 2, right? So if we apply this to the sign table, I'm writing first minus 2 and then 2 over 3. And we know that the right of 2 over 3 is going to be positive. You can just write, I mean, like 1. I mean, you can just substitute 1 into this expression if it is positive, and you will write positive sign. In every root, the signs will be changed. It's going to be minus and then again plus, I mean, positive. And in this case, we are looking for the interval which is greater than 2 over 3 and less than minus 2. So k needs to be greater than 2 over 3 and less than minus 2. Yeah. And you can just check the other questions, which is here, and write into the comment. Thank you very much for listening.